Prehistory. The first method of counting was counting on fingers. This evolved into sign language for the hand-to-eye communication of numbers which, while not writing, gave way to written numbers. Tallies are made by carving notches in wood, bone, and stone were used for at least 40,000 years. Stone Age cultures, including ancient Native American groups, used tallies for gambling with horses, slaves, personal services and trade goods. Roman numerals evolved from this primitive system of cutting notches. It was once believed that they came from alphabetic symbols or from pictographs, but these theories have been disproved. Clay tokens. The earliest known writing for record-keeping evolved from a system of counting using small clay tokens. The earliest tokens now known are those from two sites in the Zagros region of Iran, Tepa Siab and Ganj Dara Tepa. To create a record that represented two sheep, they selected two round clay tokens, each having a plus sign baked into it. Each token represented one sheep. Representing 100 sheep with 100 tokens would be impractical, so they invented different clay tokens to represent different numbers of each specific commodity, and by 4000 BC strung the tokens like beads on a string. There was a token for 1 sheep, a different token for 10 sheep, a different token for 10 goats, etc. 32 sheep would be represented by 3 10-sheep tokens followed on the string by 2 1-sheep tokens. To ensure that nobody could alter the number and type of tokens, they invented a clay envelope shaped like a hollow ball into which the tokens on a string were placed, sealed, and baked. If anybody disputed the number, they could break open the clay envelope and do a recount. To avoid unnecessary damage to the record, they pressed archaic number signs and witness seals on the outside of the envelope before it was baked, each sign similar in shape to the tokens they represented. Since there was seldom any need to break open the envelope, the signs on the outside became the first written language for writing numbers in clay. An alternative method was to seal the knot in each string of tokens with a solid oblong bulla of clay having impressed symbols, while the string of tokens dangled outside of the bulla. Beginning about 3500 BC, the tokens and envelopes were replaced by numerals impressed with a round stylus at different angles in flat clay tablets, which were then baked. A sharp stylus was used to carve pictographs representing various tokens. Each sign represented both the commodity being counted and the quantity or volume of that commodity. Abstract numerals, dissociated from the thing being counted, were invented about 3100 BC. The things being counted were indicated by pictographs carved with a sharp stylus next to round stylus numerals. The Sumerians had a complex assortment of incompatible number systems, and each city had its own local way of writing numerals. For instance, at about 3100 BC in the city of Uruk, there were more than a dozen different numeric systems. In this city, there were separate number systems for counting discrete objects, cheese and grain products, volumes of grain, beer ingredients, weights, land areas, and time and calendar units. Furthermore, these systems changed over time. For instance, numbers for counting volumes of grain changed when the size of the baskets changed. The Sumerians invented arithmetic. People who added and subtracted volumes of grain every day used their arithmetic skills to count other things that were unrelated to volume. Measurements, multiplication and division were done with multiplication tables baked in clay tablets. Conversion of archaic numbers to cuneiform. Between 2700 BC and 2000 BC, the round stylus was gradually replaced by a reed stylus that had been used to press wedge-shaped cuneiform signs in clay, to represent numbers that previously had been pressed with a round stylus. These cuneiform number signs were pressed in a circular pattern and they retained the additive sign value notation that originated with tokens on the string. Cuneiform numerals and archaic numerals were ambiguous because they represented various numeric systems that differed depending on what was being counted. About 2100 BC in Sumer, these proto-sexagesimal sign-value systems gradually converged on a common sexagesimal number system that was a place-value system consisting of only two impressed marks, the vertical wedge and the chevron, which could also represent fractions. This sexagesimal number system was fully developed at the beginning of the Old Babylonia period and became standard in Babylonia. Sexagesimal numerals were a mixed radix system that retained the alternating base 10 and base 6 in a sequence of cuneiform vertical wedges and chevrons. Sexagesimal numerals became widely used in commerce, but were also used in astronomical and other calculations. This system was exported from Babylonia and used throughout Mesopotamia, and by every Mediterranean nation that used standard Babylonian units of measure and counting, including the Greeks, Romans and Syrians. In Arabic numerals, we still use sexagesimal to count time, and angles.